Swayam Prabha. Digital India. Educated India.
All right, so lines and planes, interaction between them, intersection between them. The way they interact is by intersection. So this would be, I believe, lecture number 19, if I'm not mistaken. All right, so given a line segment and a plane, and given the projections on a horizontal plane and a vertical plane, how do you figure if these two entities intersect? Would they, just by looking at the figure? Just by looking at the figure, would they intersect? Would you know or would you not know? Yes or no? You wouldn't know. Okay, all right. How do you figure if a plane will intersect with a line or vice versa? You have the gadgets with you. You have the edge view. Somebody said edge view. No? How do you figure if the plane and a line would intersect? No. A plane, a line. Okay? Now the best way to figure that is to see the entire scenario in the edge view of a plane. Okay? Take this plane, look at the edge view of the plane and see if the plane is intersecting with the line. There are two possibilities. Number one, this guy is going to be piercing the plane. Number two, this guy is just going to be like that. There would be a gap. Yeah? If the guy is piercing, we are lucky. But if there is a gap, we need to ensure whether we can do anything about this. So let's figure. Step one, to look at the edge view of the plane. Draw horizontal, that would be parallel to the horizontal hinge line. Mark DH on BHCH, take its projection down, mark DV, and so AVDV will be in true length. Okay, make a hinge line perpendicular to that line, AVDV, shoot the projections out and measure distances. That distance gets transferred over there, this distance gets transferred over here, and the third one gets transferred over here. And this is how you get the edge view of a plane, something which is quite clear to you now. Okay, CA1, BA1, what would be here? AA1 and DA1. All right. So both these points, they will be at the same point in the edge view. Why? Because these distances, they are the same. So this line is parallel to the hinge line. Okay. All right. Now do the same thing with the line segment PQ. You have the corresponding projection points over here, P and Q. Shoot the projections out, measure distances, transfer it down there. So that's your PA1, measure that distance, that's your PA, that's your QA1. Okay? So this is what you see in the edge view auxiliary plane of that plane, of course. Now, would they intersect? You won't know. You won't know. Just by looking at the edge view and just by seeing that the line segment intersects with the edge view of the plane over here, it doesn't necessarily mean that the plane is going to be intersecting with the line and vice versa. Let's see if it really does or if it really doesn't. So the point of intersection there, project that point backwards. Of course, this point is going to be lying where? It's going to be lying on the line as well as it should be lying on the plane. Make sense? Make sense? Alright, so project that point back, MA1. Okay, it has to lie on the line. But is it lying on the plane? No? Okay. So project it upwards. It has to lie on the line, alright? MH. Is it lying on the plane? Would the plane and the line intersect in this case? No? So that's the check that you would want to make. So this point has to be a part of the line and also it has to be a part of the plane. Number one. Number two, these 2 points, they should be lying on the vertical projection. Right? Let's take another scenario. So I'll keep the plane the same. I'll change the orientation of the line in both views. Okay? Witness. You know the answer. Witness. The plane remains the same. The orientation of the line changes. Okay? The edge view remains the same because the plane remains the same. Okay? Now, shoot the projections from PV and QV. Measure the distance. This one. Transfer that distance over here. Projection out from QV. That's PA1, of course. Measure that distance and transfer it over there. Okay? PA1, QA1, join PA1, QA1, and you'll have a point of intersection between the edge view of the plane as well as this corresponding projection of the line. Okay? So that's your point of intersection. MA1. Transfer it back. It has to lie on the line. That's MV, and now you realize that the point also is within the plane. Take it up. Again, it has to lie on the line. MH. Again, it's within the plane. So if you see these signs, you know that the line and the plane, they are intersecting. Otherwise, they are not. Okay? Everybody with me? But promise we'll have a tea session someday. Everybody. All right. What's the answer to this question? Yes, come on. Yeah, better. Another case, and this is the edge view method. Edge view method, why? Because we are looking at the edge view of the plane to figure out if the line and the plane are intersecting or not. Okay? Horizontal line, the exercise remains the same. Horizontal line, take it down, true length, look at a plane which is perpendicular to this line of true length. Shoot the projections out, measure distances, shoot the projections out from all the 5 points, the 2 points P and Q, and the 3 vertices of this plane, ABC. Measure distances, transfer them. Measure distances, transfer them. Measure and transfer. Edge view of a plane. Mark the points. Okay. Measure that distance from here to here, transfer that over there, measure that distance, transfer that, and this is your corresponding projection of the line P1, Q1. Okay? Okay. Point of intersection M1 transferred back, that point has to lie on the line, that is MV, projected up, again it has to lie on the line, this is MH, okay, and of course the two projections, they lie within the plane, okay. So the line and the plane, they would intersect in this case as well, okay. When they intersect, what does that mean? A part of the line is going to be below the plane and the other part of the line is going to be above the plane, right. Now you got the point of intersections, okay. So let's erase all the other parts and let me ask you a relevant question. Which part of the line is going to be visible in both views and which part of the line is going to be hidden in both views? Once again, which part of the line, you know, you're looking at this segment, of course this part and this part is going to be visible here, this part and this part is going to be visible here, but here which part would be visible and which part would not be visible? Likewise over here, which would be visible and which would not be visible? Would this be visible or would this be visible or that? Guesses? Guesses? Would this be visible or this be visible? In the vertical plane, would this be visible or this? Huh? Wanted to see the edge view. Okay. We'll come to that. Which edge view? Nah. Okay, so what I'll do is I'll tell you something about the projection method. It is a little weird, okay, but it works. So stay with me, pay attention. So the best way to figure what part of the line is visible or not is this. From the top view or from the horizontal plane, this line is intersecting this edge of the plane, okay, and this line is intersecting this edge of the plane over here, okay. Now pay attention, follow the steps very carefully. What I would do is I would drop a vertical from both these intersection points, like for example this one, I drop a vertical. Now in the frontal plane or in the vertical plane, what do I observe? Where would this projection or which part of this projection hit first? Would it be the line or would it be the plane? In particular, would it be the line PQ or would it be the edge AB here? Once again, from this intersection point, I am going to be dropping a vertical, okay, all right, and my question is, that vertical, what is it going to be hitting first, the line PQ or the edge AB in the vertical plane? The line PQ, okay. If it hits the line PQ, then it implies that this part of the line is visible. Don't believe me. I don't expect you to believe me, okay, but I would say that this part of the line is going to be visible. And so I show that using a solid line. Now coming back to that intersection point, if I drop a vertical from there Okay, now that point represents the intersection between PQ and BC, the edge BC. Here the question I'm going to be asking is is it going to be a line PQ, or is it going to be the edge BC that vertical is going to be hitting first? BC. So that would mean that this part of the plane is above the line, and therefore the line is behind this part of the plane, and therefore I would show this using a dashed line. Okay, I'll do the same exercise starting from this vertical plane. Points of intersection that I need to consider is this intersection between PV, QV and AB, BV, and this intersection between PV, QV and BV, CD. Okay, I raise a vertical from here, go on to the top. What does this vertical hit first? AB. It hits AB first. That means what? That means what? This part of the plane is in front of the line, and therefore the line is behind that part of the plane, and therefore the line is dashed. Okay? And if I raise a vertical from this intersection point up, what is that going to be hitting first? Which line? PQ. So of course PQ is above the plane, and therefore PQ is solid. Projection method. Is it making any sense? Is it making any sense? Yes or no? Who says yes? The first time how's it making sense to you?
I don't know, getting some sort of feeling.
Well, of course, yeah. But how do you verify? Huh? The last vertical that I... No. So look at this point here. This is the intersection point between PQ and the edge BC. So if you raise this vertical from here, over there, the question that you're going to be asking is, which is coming first, the line or the edge BC of the plane? Okay, not the plane, but the edge BC of the plane. Okay, so I'll give you a clarification of this, and I'll come to the edge view. Okay, but this kind of works. And notice what's happening at the intersection point. Two things are happening. Number one, at the intersection point, a part of the line is solid and a part of the line is hidden, here as well as here. Number one. Number two, the part that is solid over here is hidden over here, and the part that is hidden over here is solid over here. Do you expect that? Do you expect that to happen? Yes or no? Is it going to be true in all cases? Are you sure? Would you like to TA about this? Think and analyze about this. Do that. Most of the examples that I have solved, I have witnessed this phenomenon. Do this. So this is something very interesting. So this part is hidden. The corresponding part over here in the other view is solid. This part is solid. The corresponding part in the other view is hidden. Okay. So the point of intersection, what it does, it changes the state of that corresponding line segment. Solid to hidden, hidden to solid. Make sense? Make sense? Okay. Now I think if I need to justify this projection method works, I have to look at the edge view. Okay. This is the edge view that you had drawn before. Okay. Now just focus on this part. This is the edge view of a plane. This is the line. Okay. This is the intersection point. Now focus on this region. Focus on this region. What is in front? Is it the part of the plane or the line? Is it the part of the plane or the line which is in front? You guys are tired. Is it warm? Huh? Did you have a heavy lunch? Yes? Come on, stay with me. Which part? So, here is the part of the plane in front of the line, or is it the line which is in front of the plane? In front of the plane. So, you're looking from here. So, this is your direction of view. Is it the plane that is in front? Rather, let me ask you a slightly different question. So, is it the plane that is closer to the hinge line, or is it the line which is closer to the hinge line? The plane is closer to the hinge line. What does that mean? From here to here, the plane is going to be hiding the line behind it. From here to here, the plane is going to be hiding the line behind it. Do you see that? Do you see that? There were supposed to be two more points over here, weren't they? Or here. I drew the horizontal from here, took this down, took the edge view of that. Yeah, so somewhere over here. Do you agree? So, from here to here, the plane is in front. So, this part of the line is going to be behind the plane. From here to here, the plane is going to be hiding the line, and therefore, it is hidden. From here to here, the plane is behind the line. Here to here, plane is behind the line, and therefore, this part of the line is solid. Make sense? Make sense? Yes or no? Good. Can you do the same thing for the top view? You'll have to draw the edge view over there. Yeah? And if you believe that this reversal happens, once you figure this thing out, go over there, this part is going to be solid, this part is going to be hidden, and you're done. If you believe that. Yeah? Okay. Another example, plane and a line. Edge view method. Horizontal, by the time we are done with the lines and planes, you guys are going to be so adept with this method that while you're sleeping, you'll be like, yeah, horizontal line, true length, horizontal line, true length, hinge perpendicular to the line of true length, shoot projections out, measure distances from where? Bottom or top? Measure distances from bottom, transfer distances, is my screen shaking? Get the edge view of the plane, mark the points on the plane, okay? Get the line in there. Well, that is the same example, just that I'm now focusing on the edge view of the plane from the horizontal plane, okay? Now here the question is, of course, points of intersections, M1, MB, MH. Okay, here. From here to here. Okay, which part? What is closer to the hinge line? Is it the line or the plane? Line is closer. So, from here to here, what's the corresponding part there? M1 to B1. N1 to B1 from here to here, right? From here to here. Which part of the line is going to be hidden? Which part of the line is going to be solid? So the line is closer to the hinge line there. Do you expect that to happen? Do you expect that to happen because the line is closer? So the plane is behind the line, and therefore this is dotted. And if you want to come down, this part is solid, so this part has to be hidden, and the other part has to be solid. Yeah? Cutting plane method. Imagine a plane in the horizontal plane in edge view that contains the line PQ. So you have a plane here, okay, that is slicing this plane ABC, and that plane is containing the line PQ. Okay? So imagine a plane in the edge plane that contains the line PQ and that slices ABC. All right? How would that plane slice the plane ABC in the vertical plane or the frontal view? Look at this point, drop a vertical down there. So this point lies on AB, the point has to lie on AB. Okay? Look at that point, drop a vertical down there. This point lies on PQ and it also lies on BC. So we are interested in that plane intersecting with the plane ABC. Okay? And of course, two planes intersect to give you a what? A line. So this is where the impression of that line is going to be. That line is going to be intersecting the line PQ. Of course, this would be the point of intersection, MV. Project it up to get MH. Once again? Once again? All right. I'm half asleep already. Plane ABC in the top view. Double A. Come up on stage. Now, did you get this T-shirt printed before the Galaxy results were announced or after the Galaxy results were announced?
Sir, before.
Huh? They got this T-shirt printed before the
Actually, this is previous class.
This is last year. So these scores, they are not the true scores.
Yeah.
They are from the last year.
Yeah. So these are better this time.
717, 715, 706. Was that?
That's not a problem. I don't bother.
What does this arrow signify?
Victory.
No, but the arrow is pointing downwards.
Then I am the victor.
Huh? Yeah. It's not a good idea, nah? So it shows Morians are going down. Well, good idea for some, not a good idea for others. Where am I? All right, so plane ABC, hold this. Line PQ, hold this. And so this is the horizontal plane, okay? So imagine that a plane that is containing the line, okay, it's intersecting with the plane ABC. Okay, plane containing the line is intersecting with the plane ABC. Hold the line. Okay. Now, this is what the scenario is. Okay, flip it by 90 degrees. Okay. Yeah, thanks. So imagine a plane which is containing this line. Okay, flip this entire thingy by 90 degrees. So you have got 2 points of intersection, one over here, the other one over here. Project these points of intersections down. So the plane is going to be intersecting with AB, and the plane is going to be intersecting with BC. It's going to be intersecting with BC over here. Two planes, when they intersect, they give you a line of intersection. This would be the line of intersection between the plane which is containing the line PQ here and this plane ABC. Okay? All right? And the intersection point between the plane and the line PQ has to be common to both PQ and this dashed line, which is this here. MV, project it upwards. The intersection point has to lie on the line PQ. This is MH. Simple? In the previous case,
the line and plane got intersected. How is the situation
if the line and the plane would not have intersected, would you have expected intersection to be happening here? It would be happening outside the plane. Yeah? Stay with me. All right, I have no idea what I'm doing, but let's see. Horizontal line, true length. Okay, edge view of the plane ABC. Projectors from P and Q out, measure distances from the bottom view, transfer distances on the auxiliary plane, get the edge view of the plane, mark the points on the plane, get PQ also. All right, so that's your point of intersection. And one, project it back onto the line PQ. That's MH. Project it down. That's MV. That's all right. Okay. Now, if you take a horizontal line here, get the true length here, get the edge view of the plane using this as the helping view. The same exercise, get the edge view of the plane there. Okay. And of course, the corresponding projection of the line. Okay. Now, look at this point of intersection here. Look at that point of intersection over there. Should they be giving you the same result? They should be giving you the same result. Otherwise, the views will be lying, which is not a good idea. So, M2 correlates with MV, and of course, MH correlates with MV. Okay. Now, if you don't want to follow the projection method to figure out the visibility of PQ, okay, you can simply use the auxiliary views. So, if you don't want to use the projection method to figure out the visibility of PQ, and if you just want to use the auxiliary views, then do this. Figure whether the line is closer to this hinged line or the plane is closer to the hinged line. Here, the plane is closer to the hinged line. Okay. So, that part of the line will be hidden. The rest here corresponding to this part of the plane which is behind the line, that part is going to be solid. Once again. All right, question. What is closer to the hinge line? The plane of the line here? The plane. So this part will be above the line, and this part of the plane will be below the line. So the corresponding part from here to here will be solid, from here to here will be hidden. Okay? Go on to the top and ask the same question using the auxiliary view. Here, which part is closer, the plane or the line? The plane is closer, right? From here to here, the plane is closer. So, which part of the line will be hidden? The bottom part or the top part? The bottom part will be hidden. The top part will be solid. And the switch has to be at the intersection point. So, keep that in mind. The switch between hidden and solid, it has to be at the intersection point. Otherwise, it doesn't make sense. Okay. Now, if I do the same thing using the cutting plane method, I hope I am doing that. No. Well, I'm doing projections. Okay. That intersection point and this intersection point, I drop a vertical from there, PQ and AC. Over here, which comes first? PQ or AC? PQ. Yeah? PQ comes first. So what part of the line will be solid there? What part of the line will be solid there? This one or this one? Yes. Get a Q. Remember this. Yeah, I guess you could do that, right? So projection method is not very difficult. So get the vertical line. Figure that PQ is above AC, so the PQ will be solid from here to here. Okay, and the rest will be hidden. Okay, and do the same thing from the bottom. Raise a projection line from here. Okay, so this is the intersection between PQ and AC. AC comes first, so this part of the line will be hidden, and the other line will be, the other part of the line will be solid. Right? So this is a nice algo. But the auxiliary view method, the edge view method, gives you a reason as to why a part of the line will be solid, the other part will be hidden, or vice versa. Cutting plane method. A plane which contains the line PQ here in the edge plane, assume that it's intersecting with the plane ABC. Okay. Get this point down over here, get this point down over here. This would be the line of intersection between that imaginary plane and the plane ABC. That line of intersection, the blue dotted line, is going to be intersecting the line PQ here. Okay. So you would realize that MV and MH, they are the same points, whether you use the auxiliary view method, the edge view method, or the cutting plane method, they would have to be the same. Okay. Now ask yourself this, and this is going to be a tricky question. Ask yourself this, and this is going to be a tricky question. So if I'm having a plane here that is containing the line PQ, and if that plane is going to be intersecting with this plane ABC, okay, here which part of the plane ABC will be in front of this plane and which will be behind? Once again, if I have a plane here containing PQ, okay, and if this plane is intersecting with the plane ABC, which part of ABC will be in front of this plane and which part of ABC will be behind this plane? Think about that. Think about that. And in particular, if you flip this scenario and come back to the vertical plane, what happens then? So that's that imaginary plane. The light blue is behind the plane ABC. The dark blue is in front of the plane ABC. Okay. This guy is behind ABC. This guy is in front of ABC, I believe. So ABC is in front of the line in the light blue area and behind the line in the dark blue area. Okay. The same thing from the frontal side. Imagine a plane which is containing PQ here. It intersects the plane ABC. Okay. How do you find the points of intersection? Raise the vertical from here to here. Raise another vertical from here to here. That is your line of intersection between that imaginary plane and the plane ABC, and of course this is your point of intersection. So whether you start from the horizontal plane or the vertical plane doesn't really matter. And again, if you ask the same question, which part of the plane will be in front of this imaginary plane, which part of the plane will be behind the imaginary plane, this is something that you'll need to think about. So the light red part is behind, the dark red part is in front. Okay, so this part of the plane is in front of this plane. So what will happen to the line? What will happen to the line? That. Think about this. Questions? Zombie.